In section 12.2 of the book, for the first lesson, I went over with you how to do mole-mole conversions. If you're not given the amount of moles of one of the reactants or products that is in the coefficient of the balanced equation, I taught you how to, using the mole ratios, how to convert from an unknown mole given an unusual amount of moles. In this section, I'm going to be teaching you how to convert, or reminding you how to convert grams to moles, so that if they give you grams and then want to know of one reactant and want to know how many moles of the product you get, you'll then now pull together everything we've learned for the last couple of months in learning how to convert grams to moles. So this is referred to as the gram, mole, gram conversions. And quite often in the problems, you're going to be given moles, and using the mole ratios I've taught you before, you're going to find the moles of the unknown. And then, as we've learned a month or so ago, you're going to then multiply that by the molar mass to get grams of the unknown. There'll be one or two problems where you'll actually be given grams of something and have to convert it to moles to then find moles of the unknown. But in general, these are referred to as gram, mole, gram conversions. Okay, so with this first problem in 46A of your book, they show carbon monoxide reacting with hydrogen to give you CH3OH, which is referred to as methanol, but I'll just call it CH3OH. And I'm just reminding you that these coefficients here do not represent grams. They represent moles. And so if the problem gives you grams, in order to then figure out how many moles of what they're asking you about and to use the mole ratio, you're going to have to convert your grams to moles. And we've been over this before. When you're converting grams to moles, you take the grams and you divide it by the molar mass. So in problem A, they gave you 3.6 times 10 to the second grams of CH3OH. I quickly went to the periodic table and figured out that the molar mass of CH3OH was 32. Carbon is 12, 4 hydrogens is 4, 12 plus 4 is 16, plus 16 is oxygen, so that's 32. When you plug it in your calculator, 3.6 times 10 to the second divided by 32 is 11.3 moles of CH3OH. So the problem's saying how many moles of each reactant are needed to produce 11.3 moles of CH3OH. And that's what we were doing in the last section. So now you're just good to go to use what I taught you in the last section. You have 11.3 moles of CH3OH. I'm just going to go ahead and use the dimensional analysis. You can set up the ratio if you want, but it's going to be easier for you if you use this dimensional analysis. You put on the top what you want, on the bottom what you want to get rid of. And so I put this, I know for the balanced equation, for every 1 mole of CO, it produced 1 mole of CH3OH. So when I multiply 11.3 by 1 over 1, I get 11.3 moles of CO. Whereas if I want to convert 11.3 moles of CH3OH and figure out how many moles of hydrogen were needed, the mole ratio for hydrogen to CH3OH is 2 to 1. So I end up with 26.6 moles of hydrogen. So that's what they were asking. How many moles of each reactant are needed to produce, when we converted 11.3 moles of CH3OH, and I needed 11.3 moles of carbon monoxide and 22.6 moles of hydrogen. In 46B, we are asked to find out how many grams of CO and H2 are required if we want to produce 4 moles of CH3OH. In the first step, we need to take 4 moles of CH3OH and figure out how many moles of carbon monoxide were required. And here I've set up, using dimensional analysis, the relationship of carbon monoxide to CH3OH. And from looking at the balance equation, it's 1 to 1. And 4 times 1 divided by 1 is 4 moles of CO. And if I try to figure out how many moles of H2 were required, then I use the mole ratio of 2H2 to 1 CH3OH, and I determine that 8 moles of H2 are required. I then use what we've learned in the past, that if I take moles and multiply it by the molar mass of the compound or molecule of interest, I can convert those moles to grams. And so 4 moles of carbon monoxide, I multiply it by 28 grams per mole, remembering that carbon is 12, oxygen's 16, so that's 28 grams, and I end up that I determined that to produce 4 moles of CH3OH, I needed 112 grams of carbon monoxide. Then, using the molar mass of 2 grams per mole of H2, I determined that 8 moles of H2 is equal to 16 grams of H2. Another problem like this, 46C, how many grams of H2 are necessary to react with 2.85 moles of CO? So in step 1, 2.85 moles of CO, I multiply it by the mole ratio for hydrogen to CO, which is 2 to 1 from the balanced equation. You always will go back to this balanced equation. And I find out that I need 5.70 moles of H2, but the problem asked me for how many grams of H2 I needed, so I then multiply 5.7 moles of H2 by the molar mass of H2, which is 2 grams per mole, and I see that I need 11.4 moles of H2. So this is the basic problems that we're going to be doing. This is kind of as difficult as it gets with this chapter. And so we'll just be messing with this for a couple of times till you get used to it. And so we often refer to this as gram, mole, mole, gram conversions. I started out teaching you moles, and now I'm just reminding you, if you're given grams, how to convert it to moles, or if you find moles, how you convert that back to grams. So for homework, I want you to complete and submit the worksheet that's associated with this mole gram conversion by the due date for each block. Every block is maybe a little different because you're now starting to rotate off at different times. Be aware that for the last couple of problems, you must convert grams to moles by dividing by the molar mass of the molecule. And then you will do a mole gram conversion. And I believe the very last problem, you're going to convert grams to moles by dividing by the molar mass. You're going to then do a mole conversion, which I taught you in the last lesson, and then you're going to do a mole to gram conversion by multiplying by the molar mass. So quite often we call these 3-step problems, and that's the most complicated it'll get.